So this is 209 parallel perpendicular lines. And some of you have already taken geometry. Some of you still are going to take it in the spring, but in geometry, you talk about parallel and perpendicular lines. Maybe you have seen these symbols from geometry. So in geometry, if the two lines are parallel, do you remember that you put these little double arrows on them? And if they're perpendicular, do you remember the symbol to show that they're perpendicular from geometry? It's a little box right here. So I just like linking. I mean, math is not in isolation, right? There's these things called lines in real life that are parallel and perpendicular, right? You parallel park your car, right? Or, streets usually cross at a perpendicular. So anyway, this is a symbol that you'll see in geometry, but for us algebraically, parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes. So mathematically, this is what we are going to be looking for. It goes back to slope-intercept form again. So we're just using slope-intercept form, and we're not necessarily graphing them. Y equals mx plus b. What is the slope of this line? We're supposed to say if the lines are parallel, perpendicular, or neither. So my slope is 6. What's my slope for this second line? -1 over 6. Are those parallel, perpendicular, or neither? So are they exactly the same? No, they're not parallel. Are they opposite, meaning one is positive, one is negative, and are they the reciprocal fraction of each other? Yes, 6 and 1/6 are reciprocals, right? 6 over 1, 1 over 6. One is positive, one is negative. So I'm going to use that symbol that shows they're perpendicular lines. I don't even have to graph them. I can tell they're perpendicular. All right, what's the slope in part B? This has a slope of 3. I can't tell the slope of line 2, so what do I have to do? Nope, because this, right, so this doesn't say, so I need to divide by 2, right? So y equals 3x minus 3. Now the slope is 3. What do they have in common? The slope. So what can you conclude? They are parallel. Back. Did you decide it was neither on part C? Because 3 and 1/3 only satisfies one of the situations. It's a reciprocal, but they are not going in opposite directions, positive and negative. So they're not going to be perpendicular, so they're actually neither in part C. So these were opposite reciprocals, these were the same, these are neither. Reciprocal is kind of a hard word. Maybe you haven't used the word reciprocal before. 2/3 and 3/2 are reciprocals of each other, but they're not opposite. The number 4 and -4 are opposites, but those aren't reciprocals, right? So you have to be reciprocal and one of them has to be negative. So down here, one of them would have to be the reciprocal, like 1/4 and -4. You can kind of visualize in your head what's happening. Here's a slope of 1/4. Here's a slope of -4, right? They're going to cross at a right angle. All right, so you are going to try, and then we're going to skip the guided practice for today, but let's try graphing number 2 at the bottom. I can already see in my head what the slope is, so I know what's going to happen. But if I graph 2x plus 4, I'm going to start at 4, up 2 over 1, down 2 over 1. And if you really want to see them as perpendicular or parallel, you probably want to draw a straight line. So my other line, it starts at -2 and goes down down 1 over 2, up 1 over 2. This one I didn't make cross at a nice intersection point, so I'm not really asking you to find the intersection point. I'm just asking you to look at the graph and show that they're perpendicular. So see how this corner right here is a right angle? If I slipped a sheet of paper, like the corner of a sheet of paper in there, right, it should fit as a 90-degree angle. See how that slip of paper fits right in there in that corner? All right, and letter B, this is kind of the harder version that we did on our quiz. We have to convert both of these into slope-intercept form. And I didn't leave you enough room. So I have 2x plus 3y equals 3, and y minus 2 equals 2 times x plus 1. So I'm gonna do my algebra down here just so I have enough room. If you want to write them down there, maybe that's easier for you. What's my first step to get y by itself? You are going to divide. To me, it's easier to subtract the 2x first. So 3y, I'm going to leave it as negative 2x plus 3. You don't want to make this 5x, right? They're not like terms with each other. All right, what's my last step? So if I write that, it would be y equals negative 2/3 x plus a y-intercept at 1. So I'm going to hold off on graphing that for just a second. Let's convert this one, and let's see if we can graph them correctly on our own in a minute. Is this parenthesis doing anything around the y minus 2? It's not, so I can just forget about it. Y minus 2 equals. Is this parenthesis doing anything on the right-hand side? Yeah. I need to do the distributive property, right? So I actually distribute the 2 inside the parenthesis. 2x plus 2. This is actually a fancy form of a line called point slope form. Maybe some of you that are ahead, next week I'll show you how to graph in point slope form because you might find it interesting. So I will make a note to self that those of you that want kind of an advanced challenge, point slope form would be a good practice for you because this is actually a recognizable form of a line to me, but we are just emphasizing getting everything into slope intercept form so that you have one method. So my last step is to add this 2 to the constant on the other side. So my second equation is y equals 2x plus 4. So you're going to graph those two lines up top and see if you can decide if they're parallel, perpendicular, or neither. You should be able to see what the result is from the slopes right now. So I'm going to pause it. You're going to take a minute, graph the two lines, and write your conclusion. So the eye might be deceiving because those are definitely intersecting. They're almost parallel, but you've got negative 2/3 as a slope, so this would have had to have been 3/2. So the slope of 2 is actually just a little bit too steep, so this is slightly different than 90-degree angles. I went back and wrote perpendicular on the left and neither on the right. Question? Oh, I wrote, yeah, so this one was perpendicular and this one was neither. Right, thanks if I said it wrong.